My name is Raj Rikhy. I'm a principal product manager at Microsoft in Azure Data. And I usually do shots of espresso over ice with oat milk.
Agents. Today we are talking agents. And it's just in time because our next virtual conference is coming up on November 13th. And guess what that's going to be about? Yep, AI agents in production. It's not just agents, it's agents in production. So if you want to join us, we'll leave a link to sign up as we do in the description. For now, talking with Raj, I had one gigantic takeaway, and it was around the question of how do I know if something is not possible or if I'm just not using the right tools to accomplish the task? Do I need to try a different agent framework? Do I need to try something different in my stack to get the desired outcome? And his response, I thought, was right on the money. We got to start with this because it feels like there's the agents that you can have that are inside of certain programs that will work that program. But then there's like open-ended agents. Then there's agents, like I just said, that they're dealing with pixels on screens. So when you look at the plethora of agents that are out there, how do you categorize them and bucket them?
I think it's helpful to take a step back and before we talk about, like, because we do want to talk about it in the context of actions, but let's take a step back and figure out, like, what are we actually talking about here, right? So agents actually, as a matter of practice, have been in the academic discipline since, believe it or not, the 50s. Like, reinforcement learning has, the field of reinforcement learning in both, things like psychology as well as things like dynamic programming. It's really been about understanding within the scope of trying to take actions on the user's behalf, right? What is the universe of things I can do, and why? And why do I want them, to do those things? And how do I make them do it better, right? Like, these are actually the principles that underlie when we talk about, like, agents. Forget about AI. When we talk about agents, right? These are very fundamentally the things that, we look for. And if we even peel back another layer, like, what is an agent, right? Forget about, like, what we're trying to do with them. What is an agent? And at the base level, an agent is some kind of an entity, software or otherwise. It's some kind of an entity that takes actions autonomously, that has decision-making power and capabilities. That's what an agent is. And I think the key thing here, to your point around differentiating agents, if we think about an agent as some kind of an entity that can act autonomously, the reason why it's useful to understand the lineage, the provenance, the history of agents, is that we can learn things that have been studied since then. So in reinforcement learning, when you're using agents, there's just by virtue of the fact that, like, we've been trying to get things done for a long time. And just for some context, like, I was part of the product team that led developing the first deep reinforcement learning platform as a service for Microsoft, like the first one that really achieved a high level of scale. And our customers were asking, at that time, there's not really a whole lot of folks that are, I would say it's being done in research, but it's not really like, oh, okay, I'm going to go deploy it in my business and kind of a thing. And there are these principles that we kind of had to educate folks on, and I think it's worthwhile to talk about them, right? So one of them is we talk about our environment. We kind of sit pen to paper and figure out what is the universe that we're operating in. Like, we're not even talking about, start coding things up. We're not even talking about, like, what model you're using. I mean, this is like verboten stuff at the moment. We just want to get a sense of, like, what are we trying to accomplish? And when you sit down and begin the process of ideating, what is your actual end goal, and what is the intended behavior that you want the agent to undergo, you've taken that very first step. And really, it literally as simple as sitting down. And this is why I think some PMs are drawn, and even data scientists who are capable of like visualizing those products. They're drawn to try and figure out like, okay, what do I want to get done with agents? Because in a very real way, what you're doing by practice of writing things down with agents is you're creating an MVP for an agent. Okay. And, when you think about like, okay, what are the different types of things I can do with agents, or what are the different types of agents? It really is a function of, okay, well, now you've written down what it is that you want. Now figure out how you're going to get it done. And so whether that means in the context of a video game, right? Your purpose, agent, is to be an enemy, to be an antagonist, and light the main character on fire, right? Like that's your purpose. That's what you need to do. Figure out a way to do that. Okay. And that's one way to think about it. Another way to think about it in terms of what you want to accomplish and how it is like, okay, how am I going to figure out how to get this guy to light him on fire? Well, he needs a flamethrower, right? Obviously he needs to figure out how to understand the environment. He needs a map, right? And these are tools. This is how an agent accomplishes its goal. It's a tool set, right? And practically speaking, when we talk about, agentic implementation, we talk about it in the form of, it's either a function call, right? Or a tool call, right? But ultimately, if we're connecting the dots here, that is the capability of an agent, right? You're describing the things that they can do. They can drive to the grocery store. They can pick up the bag of flour, right? These are the things they can do. So you've gone from defining your goal to defining what it is that they're capable of and how you can offer them things to do that. Okay.
I just want to pause for a second because I think you said something that is worth noting too on the environment piece. If we're talking about the game, the agent is playing in the game, that is their environment. If we're talking about an agent looking at pixels on a screen, that is their environment. If we're talking about an agent working inside of Microsoft Fabric or Microsoft Office, that is their environment. And so It's almost like you're putting the guardrails on. Here's your environment. Here's where you play. And this is one other piece, one other principle. Now we'll give you the tools. Now we'll give you the why or what we want you to accomplish, but it's going to be within this framework.
Right. And I think that that's important, not just because, you're thinking about the universe that they're playing in, not just because you're thinking about like what capabilities they have and what they can get done. There's this other principle about agents that, in the scope of what we're talking about is really important, which is how well can they do it? Right. And in reinforcement learning, we ascribe this principle basically around reward, right? Like folks are kind of familiar with, positive reinforcement, negative reinforcement, right? Like you want to do positive reinforcement because you want to continually reinforce the positive things. And what's the reward? The reward of positive reinforcement is praise, right? Like that's how you offer. That's quite frankly the reward. You're offering the increase in praise, which will lead to another outcome. Well, you can't necessarily praise software, although you can try. Right. But what you can do is you can define parameters for success. So in a game, that is, as an example, like let's use our flamethrower guy or flamethrower gal, right? Light them on fire more, decrease their health faster, right? Get them, 0 to fire in less than 3 seconds. You know what I'm saying? It's what are the parameters for success? Make sure you deliver that. It's these parameters of success that matter in the scope of accomplishing an agent. Once honestly, you do not need to program anything to accomplish what I just said. And that is important because as we know, programming and code development is a means to an end.
Yeah.
Right. Like it is a tool that is used that has, other types of libraries and anything that you want off the shelf to go and accomplish something. But you don't necessarily need to program to accomplish the objectives of a successful agent, whether it's in the scope of a game or scope of others. Anyway, I've been talking a lot, but let me pause there. Does that make sense? Is that yeah,
for sure. And one thing that came to mind when you were saying this is the trade-off, I think, that you get between defining how narrow you define these success criteria and how much you leave open for interpretation. And I can see how sometimes we can inadvertently shoot ourselves in the foot by defining too much.
That's right.
But I also see that you want to define more because it gives you a little bit more reliability. So there's that trade-off. There's that line that you have to walk.
You know, this is so important, right? Like, this is where, you know, the pedal meets the metal in terms of agentic development. Do you over-define? Do you not over-define, right? And the tools that we use to make these determinations are getting more sophisticated, more mature, and more abstract, which is a good thing for everybody involved, right? I think about 6 months ago, you know, as an example, the most popular, or one of the most popular repos, AutoGPT, they had this interface called Forge. It was like this UX, and they might still have it. But the point of it is that, you know, it basically functioned as this like high level abstraction where you can put in some text and the text becomes the meta prompt. And then, you know, the agent is supposed to be defined by that, right? But there's no like, it's not Facebook, right? It's not exactly the easiest UX to work with, right? And then, you know, there's this other step level thing of now we have some nicer interfaces. Now we have, you know, cleaner libraries, and now the code is more mature. There's more pull requests and things like that. The other thing that's at play here is, and this is kind of a big word, but it's used intentionally, like, is your orchestration, right? Like, what is your scheduler? Who is doing the planning, right? Are you offloading that planning to somebody else in the form of like Azure OpenAI is doing the planning for you because it has a planner behind the scenes and it's doing that on your behalf? Or, you know, OpenAI, I say Azure OpenAI just because it's the one of, you know, that's an interface. Like OpenAI has an assistant API, right? You know, there are other, Claude, as an example, has a function calling API, right? And it has a planner to figure out how it calls those functions. And so a lot of that logic is there. But if you're running it by yourself, you have to figure out what that plan looks like. So whether you're defining it like semantic kernel or LangChain or LangGraph or whatever it is, that's your responsibility. And, you know, if you're not coding it, are you leaving it up to an algorithm, right? Like, there are planning algorithms out there too that can do this. And maybe those are good for you. The point of it is, you know, the definition that you put into the environment and the criteria for success should start up front on paper. And you should have a well-oiled understanding of how success looks like before you get to the point where you're running wild. And by the way, there's one more thing that I want to just call out here. LLMs are great, right? But LLMs are random. And that is by nature, right? There's about a year ago, you know, and you probably heard this before, Demetrios, but like, you know, people are like, oh yeah, we want to reduce hallucinations. It's hallucinating all the time. It's always, hallucinations are the product. That is the product, right? Like, that is what an LLM does. It fabricates. Your goal, right? Your goal is to figure out how to effectively fabricate. And I know that sounds ridiculous, but by definition, a large language model is probabilistic and it's stochastic. It is designed to be random. Okay, it is. You can create affordances. You can create capabilities that are more deterministic, that are more planned. But that is up to you to define and to govern as the quote unquote. And I'm saying this only because, like, it's important to think of yourself this way, as the architect of that system.
Yeah.
Right? You may not be an architect. That's okay. You don't have to be an architect. What you do have to think about is that you are acting as an architect. You are, you know, the puppet master. You are pulling the strings. That is who you are. Whether you want to accept that role or not, it is important, because anything that happens in that system, good or bad, ultimately are things that you can affect, not control, but you can affect, right? Because remember, agents have autonomy.
The idea here with defining all these different pieces and recognizing how many variables you have and that you can, how many knobs you can tweak, right, is very valuable. And so maybe it's worth talking through different knobs that you want to be looking at and focusing on, or ways that you can, I think I'm thinking about it as, how can we, for my own use, I've gone and pounded my head against the wall because I don't know if what I'm trying to get done is not possible, or if it's just I'm not able to make it work because of my architecture or my puppeteering, as you will. And so I'm wondering if you've seen any good ways to just get that fast feedback loop and recognize and debug quickly.
And that's an excellent point because, like I said, right, if you are in a position where you are architecting that system, you want to figure out what failure states exist before your users or whatever, forget about the users. Like, let's say you're not designing for somebody else. Let's say you're designing for yourself, right? You want to figure out what those failure states are before you put it out in the wild, right? And you're never going to be able to discover every single one, but there are some tried and true patterns to help you figure that out, right? And I'll give you an example of how not to do it before I tell you how to do it. Like, one of the things, people, again, we're talking about the hallucinations thing because people tend to be like, people tend to be angry about it. They're like, I don't know why it's so, making fake crap up. I don't get it. I just wanted to write a legal brief, stop making up fake law cases. And, it's like, okay, listen, right? The way that, the way that you can explore what these failure states are is actually pretty straightforward. Here's pro tip. Never give your agent raw web access out of the box. Just don't do it. It's a bad idea. It doesn't matter what safeguards you put into place. Just don't do it, right? You need to give it some kind of directive, okay? Like, it's dumb.
Too much agency.
Too much agency. Yes. It's like, here's a tablet, 5-year-old, go tell
get
me what
addicted
you
to
find
Paw
out.
Patrol.
Yeah, gosh. I found YouTube, it's like the key here is vet the outcomes yourself first. And we always, even before agents came along, we would say this, like, with generative AI, always at the first iteration for the MVP, keep the human in the loop. Agents are designed to act autonomously. That does not mean that they have to action that autonomy. You have the opportunity to stopgap before that action is taken and ask it to explain the next steps that it is, in fact, going to go do. And in fact, actually, it's quite good at outputting the text kind of in like a debug log or a debug stream, what it's going to do and what it's supposed to do. You could ask it to simulate its own activities. So that's one way to do it, like a human in the loop interpretation of what it's actually supposed to do. Another way to do it is to constrain the state space, constrain the environment, right? See how successful you are with a small landing space before you go out and do a broader thing. And I'll give you 2 examples of this. Like, the first is, I have kids. I'm assuming, I don't know if you have kids, but you mentioned a 5-year-old, so you have kids. Okay. So if I give my 5-year-old chocolate milk, the first thing that he's going to do if I'm not looking, is he's going to go, run toward the couch and sit somewhere comfy. And invariably what's going to happen, it's going to get all over the couch. That's what happens. Okay. And you're like, okay, I've got to clean this up. What do I do? Well, you're not going to use a random cleaner on the most visible spots on your couch. You're going to spray it in an unaffected area first, make sure it doesn't, mess up the whole couch. And then if you're okay, then use it on the chocolate milk, right? You don't want to make a problem worse just because you think it's going to solve it, right? Like, the cleaner is the agent in this case, right?
Yeah.
So as an example, let's say that you want to create a support agent. you're not going to give it the whole compendium of your support documentation and start firing it at support tickets. That is a recipe for failure. Instead, pick, like I would say, cherry pick some of the lower priority support cases that are more clearly defined and provide it with that support documentation context and understand the behavior of how it would address those and whether you have a relatively high NPS on ticket closure or not, right? Try and create a smaller constrained environment to start with. And then the third, tool that I would say for agents, okay, is don't try and get fancy out of the box too fast.
Yeah.
I mentioned there are things like planning algorithms and, you have an opportunity to like try and offload some of that stuff. Like an MVP, if your MVP is pen and paper, then the step beyond MVP is not like, I'm going to code this up in LangChain. Please don't. And the reason why I say that is because you want to try as much as possible to understand how to action success fastest. So getting stuff off the shelf to do that, like for example, using, a function calling API or a tool API, or even if you're not a code, first person, like go find a no code tool after you've done your pen and paper and see if that solves your problem. And if it's not solving your problem, understand why it's not solving it, but don't get to the point immediately where you start going, I need to, quite literally open up the hood and start, changing my transmission before you got to Safeway, right? Like that makes no sense to anybody, and it shouldn't make sense to you, right? Like these same principles apply to software development, right? You wouldn't start writing your own database just because your relational database is not sufficient for your use case. That's crazy, right? It's literally crazy. Don't do it. But people, are like, whatever, SQL, like, just do this. It's fine, right? But these tools exist for a reason. Don't bring the burden on yourself and try and iterate from there.
One thing that going along those lines of that last point you made, and I often think about is, you mentioned AutoGPT earlier, right?
Totally.
If you were playing with AutoGPT 6 months ago or a year ago, and you were trying to use agents, and you felt like, dang, this just isn't working. These aren't reliable. What's going on? And you were trying to tailor your environment and do these things. At the end of the day, you probably would land on the conclusion of, it might be the wand, not the wizard here. Like, I wish I could make this work, but I don't think I have the proper tools, right? And so then maybe you jump to another one. And now, today, there are so many different agent frameworks and tools that you could use. Tools not in the sense of agents using tools, but us as the orchestrators being able to use tools or a product, I should call it. How do you know when the product has hit its maximum? How do you kind of evaluate that? Like, oh, this may be because this product
the limitations
that
of this thing.
Exactly.
Yeah. I think so. It's useful to evaluate it in the context of the scope of what you're trying to accomplish. And I think the AutoGPT example is actually a good one. Because let's be real, like a lot of the tools that are surrounding agentic development today are designed for code native folks, like full stop.
Yeah.
That is not only because the industry and I think the applications in the field are moving very quickly. And it's actually it's much faster to iterate when you're just working in a code native environment to try and figure out like, okay, how do you land something with these new capabilities that are coming off the shelf when people are constantly innovating, right? It does not really permit experimentation very well, okay? And that's why, and this is, by the way, this is not unique to agents. Okay. It wasn't that long ago that people were just training models everywhere off the shelf. And they were like, here you go. Like, it's a paper. Here's the code. Like, well, look at what he did. Look at what I did in this paper. I did that. and people are like, I have no idea how to reproduce this. This makes no sense. This code is spaghetti and I can't stitch, like, the variables naming doesn't even make any sense. I can't interpret it, let alone contribute, let alone reproduce it. So it's like, okay, and then Hugging Face came along, and now they have like a whole way to serve these models with inference, to test them out in a playground. So, I think it's a very, very good question. If you're trying to evaluate wands, and you don't know if it's the wand or maybe it's the wizard, right?
Yeah.
Don't go for, I'm going to go deep here. Don't go for Voldemort's twin wand out of the box, okay? Like, there is nothing wrong with the training wand. No one is asking you to bond, with, like, Severus Snape's, like, leftover wand. Like, go figure out how to start with the tools that are not bleeding edge, even the tools that are not leading edge, right? Go with the most common denominator, and there's nothing wrong with that. Okay. And if you're a code native person and you're having trouble with AutoGPT, first of all, you're not alone. I was struggling 6 months ago to set up AutoGPT myself too. The documentation is good, but sometimes you end up in challenging spots. Okay. Environment variables aren't exactly clearly documented in some places. Anyway, it's fine, right? And that's not to say that it's not a great library. It's fantastic. I've used it before. It's an excellent library. It has incredible contributors. Like, I really think that it's a great piece of software that's driven by the community. It's open source, and there are as you mentioned, there are several other libraries out there that are equally as high quality. But the reality is that if you're struggling with it, don't ask yourself, to do hard labor and explore Cavern, without a flashlight, because there are people that are doing that. Figure out a way to pair back until you can cobble together a solution that looks pretty close to what you want to accomplish, even if that's something as like a no-code solution. And that's a great way to start. Like Copilot Studio, as an example, there are tools off the shelf to do this stuff. Don't twist yourself into knots unnecessarily. Now, you asked a very important question, which is, how do you evaluate the success or failure given that you've, settled on a tool? And the answer is, quite simply, understand what success looks like. Go back to, what I was talking about at the very beginning, and be clear. Are you able to accomplish with a clear mind and a clear intent, to the best of your ability with that tool, that success criteria that you spelled out on paper? It's a very easy way of understanding the problem. And, if you come all the way back to like the no code thing that has everything, all the bells and whistles out of the box, you just can't get there, try the next step up. See if that gets you where it is. But be clear about that success before you get started, because otherwise you're going to get lost in this vortex of tools.
That's so good. That is, I have to make the point that knowing what success looks like is also not something that is unique to agents, right? No. That is something, and it's so easy to forget. It's so easy to get wrapped up in all the cool stuff and the shiny bells and whistles. And then next thing you know, you're sitting there going like, oh, weren't we just supposed to do that? I think if we may have defined this a little better, we wouldn't have gone completely off the rails.
As a product manager, whatever you want to call me, code fluent, but don't get to code, like just the person that's in front of the customer, it's just whatever you want to call me, right? Like, I subscribe to the school of thought around customer development. And the principles of customer development and lean startup are really focused on what is that granular piece of value that you're delivering. And when you talk about thinking and architecting an agentic system, like it or not, you are, in fact, creating a product. And the reason why I say that is a product is designed to accomplish a task through some combination of systems. Whether that is, software that you're writing for yourself, like whether it's like web software, you have like a database, you have an application, you have whatever, like other ancillary services, right? The point is that people are using those services to accomplish something. The difference with agents is they're designed to accomplish those tasks autonomously. You're giving them the tools to go accomplish something. So in a way, each agent is itself a product. And that gets, it can get difficult if you aren't thinking about it with first principles in mind, right? Because it can get impossibly complex if you put yourself in a situation where you say, I'm going to have an agent for literally every single task, and they're all going to work together, and they're going to have a hierarchy, and you're going to have a planner, and you're going to put all this stuff together, and it's going to be beautiful, and you're thinking about it as a conductor, and you have like this symphony, and you're this orchestra, and you're just like da 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 da. Like, please keep it simple. Please keep it simple. Please keep it simple. I will say that the best systems, whether they are stitched out of AI or whether it's stitched out of software, solve problems simply. And if you can manage to get an agent to solve a problem simply, you've won.
Yeah. Yeah. And it's especially exacerbated because if it can do something in one hop that it in other times has taken 5 hops to do, you're going to get more reliability. It's going to be faster. Everything is going to be better because it is simple.
Right. And I think, to make it accessible to folks, because I do think actually that this is, and if you'll excuse me, Demetrios, this is where I kind of go a bit hyperbolic. But I do think, indeed. I do think that agentic workflows are going to be fundamentally transformative to software. At some level, like Steve Jobs when he said that good technology is indistinguishable from magic, right? I think one of the things that has happened, particularly with generative AI, is that when we first started interacting with ChatGPT, I'm talking about like layperson, right? Like just anyone off the shelf. We immediately jump to, like, the first thing you do is you ask like a dumb question. What do you think about, Abraham Lincoln's,
Beard
speech or something, whatever, what theater, like you ask it something dumb, just test how it goes. And it gives you this educated, genuine response, and you seize it and you're like, wait, really?
That was pretty good. Yeah.
The next thing that you do is you leap to, what can this do for me? And it wasn't until the introduction, really, in my opinion, of function calls, of tools, of things that you can offer to the agent, right? Like access to the web, access to a database, access to documentation, the ability to interact with an API, the ability to perform inference of another model and obtain that and use it for the purpose of predicting something else, right? Like these are all capabilities that are inherent in agents. It wasn't until we got to the point where we can create that action space for these transformer, architecture, generative AI models, these large language models, that we were able to make the leap from what can it do for me to how can I get it to do it for me? And that is, I think, where agentic AI has such promise. But, I'm going to put this caveat that it is very early. That doesn't mean that you shouldn't educate yourself. It doesn't mean you shouldn't try. Right? Like, just because the iPhone was like the first model doesn't mean it didn't have its hiccups. Like I remember working with the iPhone first. I was like, wow, this is magic. This is really cool. I was like, I still don't understand why can't I can't figure out how to get the calling to work while I'm texting somebody. And like, I just want to text. it had its flaws. Okay. That's why software is iterative, right? We are early in the agentic software development lifecycle. Give yourself and give the tools that are offered in its stage of maturity some grace, but don't, try it and then be like, oh, it's too early, I can't make sense of it. Stay persistent, because that piece of magic that happened after you first, interacted with the LLM, it's there. You just have to dig a little bit and work on it.
Yeah. You mentioned support agents. I think that's a great use case for agents. And there's some companies that are just absolutely blowing up right now that are doing that type of thing for agent workflows. What are some other workflows that you've been seeing and you appreciate?
You know what? I'm gonna go rapid fire here. Okay.
Oh, nice.
There are so many of them. So many of them. Okay. So, all right, here we go. You ready? I'm just gonna start going off the top of my head.
Hit me.
All right. So look, you can fraud detection in finance, right? Identifying suspicious transactions and stopping them in their tracks, and contacting the user on that behalf, like intercept the fraud at that moment, right? Supply chain optimization, right? Bin packing is an age-old problem. Everybody deals with it. It doesn't matter what industry you're in, okay? But in supply chain, it's so much more acute because there's always real-time information that is throwing things awry. Being able to act reflexively is the name of the game, okay? Patient monitoring, okay? Let's say, I'm going all over the place here because there's so many applications. Let's say you have an EHR. If you know anything about healthcare, there's all kinds of information and telemetry in that EHR. There's charts, there's doctor's notes, there's intake forms, there's patient history, right? Like, if there is an issue, why are we waiting until somebody recognizes there is an issue? Why not have proactive monitoring to see if any of that data flags to see if there should be a follow-up? Totally asynchronous, but a huge opportunity for agents. I'll give you another one, offline, because people always think about online. They never think about the offline applications of agents. I got a farm, right? I've got sensors. I got telemetry in that farm. What am I doing with those sensors? What am I doing with that telemetry? I'm doing nothing with it because I have to monitor it. I have to sit on it. And I have to figure out where I want. Like, this is ridiculous. What's the fertilizer content? What's the nitrogen content of the soil? What am I supposed to do with that? No, make it actionable. Hand the agency over to an agent that can turn on or off the water, apply nitrogen through some kind of a drone or some kind of a distribution system.
And seeing that, that's cool.
I'll give you another one that I really love. Here's another one I love, okay? Personal shopping assistance. Take a snapshot of your closet. Forget your closet. Load up your social media, okay? Connect your Instagram account, all right?
Aspirational.
Yeah, totally. Whatever, okay? Get your LLM some idea, your multimodal LLM some idea what you're wearing. Have it scour the web for your brands and recommend you the clothes. Why are you looking for the clothes? Is it in? Look, this is and the sales. Yeah. Okay, forget about the clothes. What about the sales? Right? Have a personal shopper. Why? Nobody's saying don't go into the store, but don't you want to know, like, why? What our alternative here is, Demetrios? It's RSS feeds. It's RSS feeds. That's the closest approximation you have. People are parsing through emails and pamphlets to figure out, like, how do I get the best deal with the thing that I like? Why are you doing that? Don't do it.
That is such a good one. I actually saw the other day somebody created like a Tinder, but for clothing items, and you could swipe right and swipe left. And so if you swipe right, it saves it, or it will take you automatically to that. But that's novel. That's not your shopping assistant that can say. It would be even cooler if it could say, hey, I just got you 5 shirts because you're thinking about getting a new shirt. These are all on sale. You've showed interest in them in some way, shape, or form, or you have one of them in your closet. You have been watching videos on TikTok about these types of shirts. But going back to, there is something that I wanted to point out with those first 2 use cases that you mentioned, which is that they're very real time. The fraud and the supply chain are very real time. And in my mind, the use of LLM and real time never really went together because it is so slow, right? And so like a fraud, you can't be sitting around for 2 minutes waiting to see if your credit card passes.
So I'm actually really glad you brought this point up, to be honest. I think that there is a huge investment opportunity that has yet to be fully realized, and movement around small language models. I think we've looked at LLMs as being a generalized set of capabilities that offer, a wide variety of possibilities. But I think that, as the maturity life cycle of, as an example, do you know how many possible computer vision models, specifically models, have been trained? I mean, innumerable. Like, here we are talking about like Llama 3.1, Llama 3.2, Claude 3.5, like get down to your dealership and get, Whale, Whale 7.53, it's like, look, the point here is that the accessibility that small language models represent for latency and inference, and said plainly, right? The smaller you get, the less expensive it is, the more accurate it potentially is, and the more powerful it is. Okay.
Yeah, and the fast.
And the faster it is, fundamentally. And the faster it is. The cheaper it is, the faster it is. There's also a parallel movement that's been going on around, quantization and parameter efficient fine tuning. And I think that, as we start exploring a lot of these use cases, the inference cost, whether that is done in terms of tokens, whether that's done in terms of latency, whether that's done in terms of, RAM size, right? The actual compute resources that are required for inference, we are going to continue to see that decrease and decline. This is the part where I have to say that, this is kind of on more of the bleeding edge in terms of the return on investment. But the key here, the important thing here is, if you can get yourself and your application to the point where, inference speed and cost is the problem, you already won. Because you've already solved the problem of, have you achieved your goals? Have you delivered success? And there are tools out there that will allow you to do it. And even if you have to go and hire data scientists to figure out, like, how do I train an SLM on this data set? Or how do I provide, like, a graph rag interface that will make this more efficient and quicker? How do I reduce the amount of resources that's associated with inference because I'm getting too much, consumption downstream on my API? Like, these are great problems to have, right? Especially if you deliver in real time. Like, if you can prove that the value of supply chain optimizations happens in a time series, right? If you simulate the outcomes and you can showcase that you're more efficiently allocating resources in your supply chain, and you can do that effectively, and the only barrier to entry is that you need to make that faster, you are in a very good spot, my friend. You are in a very good spot.
Yeah, that is a great point. The speed is the last thing. There's so many other questions that you need to tackle, or so many other obstacles, we could say, and hurdles that you need to get through. By the time you get to speed as the hurdle, you're looking good. And so
Yeah.
Instead of jumping, I guess I kind of jump to the end and say, whoa, is it ever going to be that fast? Yeah, I understand there's distilling. I understand small language models, but I also see the side of if I'm doing fraud and it has to be quick. I do think there is a world, though, a little tangent, where you get these workflows that are using a combination of small language models plus just traditional machine learning, plus you've got these workflows that are plugging in. And again, going back to that orchestration, each step on the orchestration, whether synchronous or asynchronous, it doesn't need to be every time there's a step on the orchestration or agentic workflow, it has to be a LLM call or just small language model call. It can be a regular regex. It can be whatever you want it to be, right? And so whatever you find as the most optimized, and also then going to that, because I know people, when they go into production, one of the very difficult parts of, again, walking that tightrope of the trade-offs is, yeah, we can get it fast, but we can't get it reliable.
Yeah.
Once you start trying to shave off time, then you start seeing the accuracy go down. And that's a classic problem that is as old as machine learning. If we're going back to the 50s, as you mentioned, since agents have been around, that's kind of been the name of the game.
Yep. And I think, look, here's the deal. You're not alone in this. Like, it's human nature to confront something that is new and make a justification why that new thing will fail. And whether that is intentional or unintentional, whether that is justified or not justified, I think it really behooves us to kind of see past those initial objections and figure out, is the value worth it? And quite frankly, am I just saying it's not going to work because I don't really know how it would work?
Yeah.
Or am I just saying
I want to rain on the parade? Yeah.
Yeah. Or I just want to discount the potential, right? It's okay. Nobody's going to fault you for calling out what are quite frankly the main impediments to rolling this thing out at mega cluster scale, right? Nobody's, if you go to somebody on the street and they're like, why don't I have ChatGPT everywhere I look? Well, yeah, I mean, it's a problem. I mean, there's other stuff, the work you got to do. But the truth is that, all of, I wouldn't say all, but like there's an incredible concentration of minds that is focused in trying to figure out alternatives to these objections. And just because they're working on it doesn't mean they're going to solve it, but it also doesn't mean that you can outright cast it out.
Yeah. Right? That put a very, not scary, but fun picture in my head of, like these brilliant folks with their candlelight just working on figuring out how to make this, how to get this working. And it's like this army of smart people. And then me, the naysayer, being like, nah, that shit ain't going to work.
Yeah, right. It's like,
dude, you know how many smart people are working on this problem?
Yeah. But it's fine. It's fine. Like, we've seen this happen everywhere. People said the same thing about the web. If I'm being totally honest. Look where we are today.
Yeah, we're having a call. You're halfway across the world. And we're having a video call, nonetheless, on the web.
There you go.
In the browser.
In the browser.